The See You Later Amazon Rater is an implementation of a sentiment analysis project that utilizes text from Amazon reviews in order to predict the sentiment, either positive or negative, for a given review of Amazon products. This is a binary classification task with input review text and output rating that we chose due to our shared interest in natural language processing, as well as the insight about word connotations that such a model could uncover. We extracted our data from a smaller subset of UC San Diego's Amazon product dataset. This diagram shows how we pre-processed the review text and extracted the training and testing data from our dataset, which generally involved filtering out stop words, lemmatization, and normalization. To extract the labels, we looped through the numeric ratings, and if the rating was greater than the sentiment threshold, it was classified as 1 and 0 otherwise.
For our model, we varied the type of embedding layer used such that we could compare a standard Keras embedding layer with a glove embedding, both of which are means of converting word IDs to vector representations. We used two GRU layers followed by two dense layers with ReLU and sigmoid activations respectively. The final output from the second dense layer was a single value, 0 or 1, where 0 represents negative sentiment and 1 represents positive sentiment. For the results of our comparison between the two different sentiment classification models, the GRU with glove had an accuracy of 76% over 10,000 examples. This consistently outperformed the base GRU model, which had an accuracy of 73% over 10,000 examples. Here's a visual representation of our loss functions over the 10,000 examples for both models, with and without glove. While the loss showed us a general downward trend, it was difficult to determine whether it stabilized due to limitations on the number of examples that we were able to train the model on.
Aside from computational limitations, we also faced an issue with imbalanced class distribution, given that most of the reviews were given ratings of 4 or 5. For future work, we could consider implementing the same models for multi-class classification rather than binary classification, which might involve additional sentiment categories or directly predicting product ratings from 1 to 5. We could also potentially expand our comparison to include other types of models and account for more complex features and edge cases such as punctuation and numeric data.